Hi guys! So today I'm going to show you how to do this effect. Alright, let's get to it. So I'm going to go in here and I'm going to drop down a geometry. The first thing we need to do is to get a container that the different cubes are colliding with. So I'm going to drop down a box here. I'm going to make this 20. I'm going to move it up by 10. Like so. And now it's just a box, so let's go and delete the top one here. And now we just need some thickness. I'm going to drop down a poly extrude. And I'm going to make this 1, like so. And then I'm going to drop down a null. And I'm going to do out container, or out box. And I'm going to color this black. So next thing we need to do is to get an emitter. So I'm going to drop down a grid here. And I'm going to move it up 25. So it's up here. I need to scatter some point on every frame. So I'm going to put down a scatter here. And I'm going to do 50. And right now nothing is happening if I drag the time slider. But we could make a change if we move these global seeds. So let's just drive this by the current frame. So now they are moving. I'm going to put this to real time. So let's continue, and I'm going to drop down a copy to points, like so, and I'm going to drop down a box that I'm going to copy over the points. So now we have those here, and they are changing on every frame, but the orientation is a bit dull at the moment, so let's break this up a little bit, and I'm going to do this by a hack. So I'm going to drop down an attribute VOP. I'm going to go in here and I'm going to drop down a noise. I'm going to take the point position here. I'm going to set this to 3D noise because I want to have a vector out from this noise. And then I'm going to normalize this vector. So I'm going to normalize. Because I have a random normalized vector, I can use a rotate. And for the axis that the rotation is going to be around, I'm going to use this vector. And then I want to get this out to a quaternion, because I'm going to use orient, and that is a quaternion. So like so, and I'm going to do bind export. And like you might know, a quaternion is the same thing as a vector 4, so like so. And I'm going to do orient, and nothing happened. It's just because we haven't set an angle. So let's drag this up. Now we can see we are breaking up the orientation a little bit. And the reason we get this drastic result with just 1 is just because it's radians and not degrees. So perfect. So let's just go to this copy point and do pack and instance and drop down a null and out emitter. And I'm going to call this black too. And now we can drop down the dopsim. So a dop network in here. And I want a rigid body solver. And in this I want to use an RBD packed objects because we have packed primitives that we're going to use. So let's connect that into this. And then we're going to drop down a pop source that we're going to use to pick up these emitters. And also let's go up here and just select this dopnet so we see what's going on. And in this pop source we're going to connect this to the second port here. And instead of scatter on surface, we're going to use all geometry, which means that now it's going to pick up all geometry from the subpath that we're going to specify here. So let's go in here and do out emitter. So suddenly we have these guys, and let's also put a gravity so they can be falling, like so. Perfect. But I don't want them to emit on every point, so I can go to birth here, and on this impulse, if this is 0, nothing happens. If it's 1, it will emit. So let's do $f in like a frame modulus 2, and I'm going to do if this is equal to 0, which is going to be on every other frame because that's how modulus work. So every time it's going to count up towards 2 and go back to 0. So if I would do, like for instance, if I would do 4, it would be every 4th frame. So if we look at this, emits on every 4th frame, but I'm going to have it on 2, like so. So perfect. And the next thing I want to do, I don't want them to emit forever, so I'm going to have a cutout point. So I'm going to do an AND here, $f, and if f is less than 100, then it's going to emit, but after that it's not. So now it's going to stop after 100. The only thing we need now is to have it to collide with something. So let's drop down a merge here. And I'm going to have a static object. And this static object, I'm going to select the box. I'm going to connect it in here. And because of the merge, left inputs affects right inputs. So we want this guy to be affected by this guy, so we need to change the order. So I'm going to click this up arrow here, like so. And if we look at this, we can see that it's not going in the box, it's settling on it. And that is just because the default behavior is a convex hull. Oh, sorry. Let me go to collisions here. Bullet data, convex hull. And the convex hull can never be concave, so let's go to concave instead. So if we do that, and then we're gonna hide the geometry. So let's see what we have now. Perfect. Cool. Now we have a working simulation, so let's go out again, and I'm gonna use a dop.io to import whatever I want from this dop sim. And I just want the RBD packed objects, so let's first select the dopnet, and then I'm gonna select the RBD packed object. RBD packed object, and we don't get anything because we need to tell it to import a field. So I'm gonna click the plus here, and you could put RBD packed object in geometry here, but you get it anyway, so you don't have to. So now we exported our animation, and I'm just gonna go to the save tab, and then I'm gonna do save to disk. Okay, so now it's saved out, so I can just take load from disk, and now we have our simulation here. So now we just need to project a material on this one. So first let's create a material. So I'm going to go to material, I'm going to drop down a principal shader, and I'm going to go to textures here, use texture and base color, and choose this eye texture, like so. And I'm also going to change the surface base color to white, so we see it a little bit better. Cool. I'm going to apply this on this geo1 here. So material, and use the principal shader. So now we see that something got applied, but we don't have any UVs, so we don't get the texture yet. But so let's first unpack it so we get some geometry, and then we're going to project a UV on this one. So now we've unpacked it. We're going to use this UV texture. And let's go in here, and I'm gonna do it on from the X up, and now we see we have something. But we can see that the UV doesn't follow the cubes. On every frame it reprojects, but we want the simulation to have a consistent UV through the whole simulation. How we can get around that is to drop down a time shift, and let's do the time shift here, and on frame I'm gonna do F end. So now we're just projecting on the last frame, so if I go, nothing happens. We of course want the whole simulation, but what we can do now is use an attribute copy, like so, and then we can take the simulation, and then we can take this to the last port, and here on the attribute name we can copy UV. So now we are copying the UVs from the last frame on every frame, which means that they're going to be consistent through the whole simulation. So yeah, that's it. So I hope that you found this useful, and see you next time.